Okay, so yesterday we learned determinants, and one of the questions was, when will we ever use matrices in real life? And the one who asked it is in the restroom. But there's something called eigenvalues. We're not going to learn about them, but matrices are used to determine eigenvalues, and eigenvalues are actually used to power the Google search engine. So programmers definitely need to know matrices. Will you need to know matrices in real life? Depends on what career you go into, but you'll definitely need it to get through Algebra 2. So I guess there is real life application for you after all, right? No. So really what we've been talking about with matrices and why we care about it in Algebra 2 is we use matrices to solve systems of equations that before this we had to do manually. 2 equations, 2 unknowns, 3 equations, 3 unknowns, right? Yesterday we learned determinants, and today we're going to apply determinants to something called Cramer's rule. And Cramer's rule is one way to use matrices to solve systems of equations. Okay? So I put a system of equations up here, 2 equations, 2 unknowns. To use Cramer's rule, you're going to come up with a determinant called the coefficient determinant, or the matrix, coefficient matrix. What's a coefficient? The number before the variable. Okay, so what are our coefficients in this system?
3, -1, 5, and 2.
Okay, so that is what they refer to as our coefficient matrix. Everybody follow where those numbers came from? Yeah. Okay, so to find x using Cramer's rule, we're going to have a numerator and a denominator. Okay, the numerator is going to be a determinant, and the denominator is the determinant of this. What is the determinant here? How do we do it again from yesterday?
3 times 2 minus 5 times -1.
Okay, good. 3 times 2 minus 5 times -1, which is 6 plus 5, 11. Okay? So the determinant of the coefficient matrix is 11. Everybody follow so far? Okay, so to find x, what we're going to do is we're going to take this coefficient matrix, we're going to replace the first column, because the first column was our x coefficients and the second was our y's, right? We're going to replace the first column with the constants. And that's how we find x. Everybody follow what I did? Replace the first column with the constants. Okay, how do you think you're going to find y if we follow the same pattern? Replace the second, Blaine said. Replace the second column with the constants. 3, -1, 3, 10. And that's also going to be over 11. Yes?
I'm confused on where you put the 3 and 10. Like,
Yep. If I'm trying to find x, I'm going to put the constants in the x column, the first column. And I'm going to leave the second column the same.
Oh, okay.
And if I want to find y, I'm going to replace the y column, which is this column, with the constants and leave the x column the same. Does that make sense?
Yeah.
Good question. Okay, so what is this determinant? 3 times 2, right? Which is 6 minus 50. 6 minus 50.
-56. 54.
44.
-44.
Oh.
Lots of answers. Okay, so what's -44 over 11? -4. So x is -4. What's the determinant here? 30 minus -3, right? Which is 30 plus 3. 33 over 11? 3. Y is 3. Yep. And I'm going to make it even faster. Everybody have a calculator. Yep. There's one right behind you. Oh, you can take this one. Okay, I want to teach you how to do matrices on a calculator. On the quiz, when we do a quiz over this, I will expect you to know how to do a 2x2 and a 3x3 determinant by hand. But when it comes to using that information for Cramer's rule, I will let you use a calculator, and I'm going to show you how to do it with a calculator, okay? So does everybody see the matrix button? It's, you see the x to the -1 button? And the blue letters above that say matrix? Okay, so to get there, you're going to have to do the second button and then press matrix. So everybody do that. And you should get a screen that looks like this. Right? In order to input your matrix, you're going to scroll over where it says edit. Okay, and with mine, when I scroll over where it says edit, for number 1, it has A, and then the dimensions of A for me are 2x2. Okay, if your dimensions are something other than a 2x2 and you want to type in a 2x2, you're going to enter that, and then you can change the dimensions. Since mine's a 2x2, I don't have to change anything. So everybody see that? We're going to put in a 2x2, and we're going to do this determinant. Okay, so everybody, you've got 2x2 showing. Press enter until you get your cursor in the first cell. Type in 3, enter, 5, enter, -1, enter, 2, enter. And then your matrix will look just like this one. Is everybody with me so far? Good? The ones on the board, 3, 5, -1, and 2. And all you do is press the number and then enter the next number, enter. You good? Okay. I've got my matrix loaded now. I can leave the screen, and my matrix is still in this calculator as matrix A. Okay? So go ahead and clear your screen. Everybody know how to do that? Hit second mode, and you go back to the regular screen, and then you can hit clear. Okay, we're going to go now and find the determinant of matrix A. So you're going to go second matrix again. Now instead of going to edit, you're going to go to math. And you see the very first choice with math, it says DET with a parenthesis. Yeah? Hit enter. That parenthesis is open. Don't hit enter yet. We need to enter the matrix A in there because we want to find the determinant of matrix A. Okay? So you're going to go second, back to matrix. And now names. Do you see how matrix A is highlighted? Under names. You don't even have to arrow over now. Just hit enter, and it'll pull matrix A into the parentheses. So your screen should look like this. Everybody so far? You guys have this? Okay, hit enter. What do you get? 11. What did we get? 11. Did everybody get 11? Okay, we can do this with a 3x3. Does everybody like doing 3x3 matrices by hand? Yeah. Not so much. It's not bad. It's a lot faster once you get the hang of using the calculator. The description on how to find the determinant using the calculator is in the textbook, and I'm also recording this, so if you want to go back to the recording and listen, okay, you'll be able to do that. And again, how would we have solved this system before we learned Cramer's rule? Which method would you have preferred? Elimination? What would you have done? Multiplied this by 3. So then I would have ended up with and negative 3x minus 6y equals 30, right?
Wouldn't that be plus 6y?
Thank you. So then we get 11y equals 33. Y equals what? 3, which is what we got. Right?
Yeah.
Okay, so this is just a technological way using the calculator and something called Cramer's rule to solve systems of equations. We're going to learn next how to find inverse matrices and using inverses to find solutions. I like that method the best. It's even better, faster than Cramer's rule. You give me a system of equations and a calculator, and I can use a matrix, and in about 15 seconds solve a 3 by 3. Okay, which is much easier. You will see a matrix question on the ACT. It's probably not going to be something you have to remember Cramer's rule to solve. It's going to be something like a matrix multiplied by a scalar, having to add two matrices together, something like that. But you will see a matrix problem on the ACT. Do you have a question?
My sheet from yesterday.
Your sheet.
My worksheet, the sheet that I was doing.
Where was that at?
It's in my locker.
Yes. Okay, let's go to, who remembers reading in the textbook what happens when that coefficient matrix is 0? Good. So when you actually, if you find that determinant here to be 0, what are possibilities for that system? What would it look like graphically? What does it look like graphically when there's one solution? Two lines intersect at one point. So if it's 0, what are our possibilities?
Crossing at many different points.
Which would be infinitely many, same line, or
No solution.
which would be
Parallel.
two parallel lines. Okay, so you aren't going to be able to find a solution if that determinant is 0. Okay, anybody think they could set up a 3 by 3? What would my coefficient matrix be? Who's talking? Lacey, tell me out loud so I can hear. Okay? Okay, everybody see that? Just the coefficients. That will be your denominator using Cramer's rule on a 3 by 3. So what do you think I would do to find x? With the constants? Replace the first column, the x column, with the constants. For y, replace the y column with the constants. Z, replace the z. So it's the same process as we did with the 2 by 2, but now you're going to do it with a 3 by 3. Good? Okay, let's go through the check. If I can find it. All right, to use Cramer's rule to solve a system of equations, you need to find the determinant to use in the denominator. The determinant is created using what numbers? The coefficients of the variables. Yep. Question 2. Once you've found the determinant to use in the denominator, you can solve for x and y. To solve for y, you replace what? The y column with the constants. Good. Question 3. What does it mean when the determinant of a equals 0? No solution. Not going to be a single point. It's going to snow tomorrow. Did you like that answer? What was the comment I made at the end of the video?
You will do one and
Yep, you'll do one 3 by 3 determinant on the test manually, but for the rest of the test you can use a calculator, now that you know how to do it. Okay, and the question 5, who presented? Sousa, James Sousa, good. Okay, questions on 4.3 or 4.4? Everybody finish 4.3. You have a question on 4.4? What is that? Okay, give me the vertices. Just a second, my board's being -2, 3. Okay, who remembers the formula using a matrix to find the area of a triangle when you have 3 points?
Plus minus.
Plus or minus 1/2.
5.
What do you multiply that by? It's a matrix, but it's the straight line. What does the straight line mean? What goes in the last column? Ones. What do the straight lines mean? Matrix has the brackets. Determinant. Straight line means you take the determinant. Okay, this will be a good review from yesterday, how to do a determinant of a 3 by 3. Right? Rewrite those two columns. I'm going to take the diagonals. I'm going to start this direction. And what do I do with those diagonals? Multiply the diagonal, add it to the next product and the next. Okay? -2 times 4 times 1 is -8. 3 times 1 times -3, -9. And then 24. Right? And then I'm going to subtract the diagonals going the other direction. So this is -12. This is -16. And this is 9. Everybody comfortable with the determinant of a 3 by 3? What are you lost at, Kirsten?
I don't know.
So I have the 3 diagonals going this direction. That's how we find the determinant of a 3 by 3. That's just how it is.
Because I honestly say,
No.
did I not swear?
Okay, what's -8 minus 9 plus 24? 7. And what's -12 minus 16 plus 9? Well, this is what? -28 plus 9? -19. So I add the two together. Right? So now we're trying to find the area, right? The formula is half of this. So it's 13. If my determinant had been negative, that's why we put the plus or minus there. Because I'd be multiplying it by -1/2. It's essentially taking the absolute value. Is that right? Look at that. Any other questions on the work from yesterday? Yes? What is that one? Okay, anybody else still struggling with number 3? Okay, you're probably just getting confused in the nomenclature. All it's asking is the matrix C is the product of A times B. So you're going to multiply A times B like you have been doing since section 2. You're going to end up getting a 2 by 2, right? What are the dimensions of A?
2 by 3.
2 by 3. Remember, when we determine whether they can be multiplied, we write the dimensions down. What are the dimensions of B?
3 by 2.
3 by 2. If that inside dimension is the same, it can be multiplied, and the resulting matrix is a 2 by 2, right? So, Raven, when you multiply A times B, you should get a 2 by 2 matrix. Now, where it says C11 and C12 and so on, well, C11 just says, give me the number that's in the first row, first column of your matrix. Does that make sense?
Yeah.
So it looks a lot more confusing than it is. It's just wanting you to multiply A and B. Then flip it and multiply B and A. Okay? Does that help in how to do the problem?
Yeah.
Okay.
May I go get my finger?
Yes. All right.